Hi everyone, welcome back to the channel. Until now, we learned Python step by step, right? Like variable stores the data, loops, repeat actions, functions, group logic, right? But real software, real robots, real AI systems are not written as random functions, right? They are written as objects. Here, like chatbots, AI agents, voice assistants, RAG systems, and LangChain tools, all of them are built using object oriented programming. In today's episode, we will understand OOPS concept from zero level and slowly we will reach advanced AI engineering level. Okay? Like with very clear examples and explanations. Here, let's see what is OOPS. OOPS nothing but object oriented program. Simple meaning writing programs by thinking in terms of real world objects. Okay. Here, real world objects, for suppose a robot has some data like name, battery, sensors, actions like move, speak, scan the particular area like that. In Python, data nothing but variables, actions nothing but functions. When we combine data plus functions together, we get an object, right? Here, why oops exist actually? Without oops code becomes some type of messy, some type of clumsiness it will come. Okay, data is scattered, okay, hard to scale, difficult to debug. With oops, like data stays with behavior, easy to manage large systems, reusable components, like clean architecture. We can design clean architecture with oops concept. AI systems cannot scale without oops concept. Okay, here let's see what is a class. A class is a blueprint. Think like blueprint of a house. For suppose here, class nothing but blueprint of a house. For suppose, and what is object? The actual house is the object. Okay. Here, for suppose robot. Class is a robot. Objects. What are the objects? Chitti, RoboX, RoboY. Some same principle but different types of robots. For suppose same class here, in while coming to a movie, one good robo is there and bad robo is there. After inserting the red chip, both robo functions are same, but the class is robotic class only, but the functionings are differently they work. One is used for creating new things, creating you doing useful things. One is to distraction power. Okay, like that the class is same but different types of functionality. Based on the functionality it will behaves. That is the major difference, right? Let's see some coding. Okay, how to code, how to define a class from low level to advanced level we will see. Okay, let's see. Here, for suppose let's go to VS Code. Here I already created one class object python file dot class underscore python file dot. Now let's see here how to define the blueprint. Like class robot. For suppose robot is a class. First just pass it, simply pass, it will work. Pass. Here, class, the keyword to define a blueprint. Okay, to that is the keyword. Class is the keyword to define a blueprint. Here robot is a class name, like here robot is the class name. Pass means like empty placeholder, nothing is there. We are building a house plan name is a robot, and in that there is nothing is there. We didn't put anything in that house. That is pass means nothing is there. The class does nothing at, okay, but the structure exists. House is there but no one is there. That's it. Now let's creating an object. How to create an object? First, suppose we already define a class. Now Chitti, we are giving the name, is equal to robot. Like this we have to call, we have to give. Here robot, it means creates a new object in memory. New object in memory, nothing but variable holding that object. Here it's creating a new object in memory, and variable chitti holds that object. Now chitti is a real entity in RAM. Chitti is the real entity, okay, real name. Here let's add some data attributes. Now we add properties to our robot. Let's see here, class robot diff underscore init. I will tell what is init, wait. And here we are defining self name battery, and here self dot name is equal to name. I'm writing the program, I will explain. Self dot battery, like this. Here what it is, next line, self dot battery is equal to, here what it is actually, here dunder init dunder nothing but two underscore double underscore we call as dunder double underscore, two times underscore, shift minus button you click, no underscore, it will come dunder init under. What it is, it is nothing but in Python language it is a acts as a constructor like the tapi man in to build house, okay, runs automatically when object is created, okay, when object is created. What are the objects? Here self refers to the current object, self nothing but current object. Here self dot name attribute stored inside the object, the name is stored inside the robot object, okay, robot is the object. Here self nothing but itself, we are calling robot. In that robot we are storing that names, object values, okay, that is name, and creating name and battery we are storing in object, okay. For suppose now from this class we can create any number of robots. See, chitti is there, chitti is equal to robot hundred pattern 100 print dot chitti dot name, sorry, here print dot not required. Now again print bat chitti.battery. Here each object has its own copy of data. Here see, like this you can call the objects. What is chitti name? Chitti 3.0 and battery level is 100, like that. Also you can format it, no problem. Robot name, like that we can call. Okay, same robot. Here also, here you can give robot battery level. Okay, like that you can give. Yeah, robot name chitti, robot battery level 100, like that it will give. Here in this way we are creating object by using this. We can create any number of robots like that. For suppose terminator 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 is equal to robot. Here you can, the name you can give any name, megatron megatron 4.0 comma battery level 100 or 90, like that. You can create any by using robot object. You can create any number of, simply you can print these, but instead of calling chitti we have to call terminator. Simply see, with same neural schema. In robot movie Rajnikant, what he did, he created one robot and give power to that robot to create one number of robots, same neural schema, but it creates same with, by using that blueprint it creates number of robots, like that. The class useful like this only. Just we have to define the formula. Class is just a formula and class is just a blueprint. In that blueprint it will contain, what is that, it will contain these values, these things it will contain. This is the class, this is the class. In that class what we define, name and battery only. You can use any type of attributes, battery level, and sensors you can give, right? Here you have to mention self dot sensors is equal to sensors, like that. And here you can call sensors is equal to anything. You can call thermal sensor, thermal, like that. Here motion sensor you can assign, like this. Okay, yeah, this sensor we did not print, that's why did not given. You can print sensors also, like this. If you print, see, it will give thermal sensor for robot, like that. For all terminator also you can give like that. Here this is the formula. By using this formula, this neural schema, we can create any number of, right? For suppose Megatron, also you can create Terminator 2. Terminator 2 is equal to any robot, that is a robot, no? Anything you can create, bumblebee name you can create, and you can give battery level bumblebee 80, and sensor you can give infrared, like that you can give. You can simply call this. Okay, you have to call that variable. Okay, you have to call that variable. You can simply call it. See, Terminator, Bumblebee, Terminator 280, battery percentage, infrared, thermal. We did not mention that names. If you can mention also, you can mention, it will give, this is user defined. This is user defined. As per our requirement, we can give the name. But here, whatever that variables you created, variables we defined, that thing we have to give. I hope you understand, right? What is class, how class will be used. Class is like a blueprint, just blueprint, that's it. Based on the using that blueprint, we can design any number of houses, any number of robots, like that. Here, what is self? You may get doubt, right? What is self? Self means this particular object, what is that object? Robot. Here robot we define, that is object. These are belongs to this object, robot object. Okay, we are initializing, it is this, it will construct, it will interact with the robot, it will connect to the robot, this initialization. Okay, runs automatically, right? When you write a chitti dot, for suppose any chitti dot speak function, Python internally converts it to robot dot speak chitti, like that. Okay, I mean, it means it will connect with the object, and object is robot dot speak, like robot dot any function you defined. Like here self is nothing but chitti, whatever we define, that is. Okay, here without self, Python cannot identify which object is calling the method. Okay, now adding behavior, here adding some behavior. Here methods, we are introducing one more. Methods is nothing but functions inside a class. Methods nothing but functions inside a class. How to use functions inside function inside a class? Let's see. For suppose, now let's define one more function. Define function speak. Sorry, here indentation. Now let's here itself, let's create it's here itself only. Forget these things, forget this. Let's here itself, I want to create one more function inside the class. I am defining speaking function self. Whenever you write a function inside a class, definitely you have to use self. Whenever self refers to that object, you are giving one functionality, we are giving one functionality to the particular object, it will remains within the class. Whenever you call the robot, it will refer speak function also. Okay, for suppose message is there, print here self dot name comma says something like Chitti says something message, some message, something is telling Chitti. What is that? Message. Here, here, Chitti is equal to robot, not Chitti. It is Chitti. Chitti is equal to robot. System is online. Speak function we already defined. Okay, just comment these. Okay, here something is going. Sorry, here Chitti dot. So why it is highlighting? No, we created three values. So give some thermal. Okay, now let's execute. Chitti says system online. Here like this speaking function. We are calling the speaking function, right? Previously here we did not call any functions from the class. Here we are simply printing the statements, printing the variables. Here calling the functions from the class. Here the function inside a class is called method. We are calling the speak method, speaking technique. Here without this also it will work. See. No, it won't work. It won't work because we did not define the variable. See here it won't give all the things. Simply chitti says system online. This one not required. This did not, we are not printing this. If you want to print, you can print simply print chitti. Not here. See what it is giving, dunder main dot robot object. Here we given the robot, but we did not given the objects. What to give, what to call the name, so many are there in this. Name is there, battery is there, sensor there. What we are calling, we have to specify chitti dot name, you can, or chitti dot sensor. See, thermal, like that, like this. You have to understand. Now let's see multiple objects from one class. From one class, how to define multiple objects. Let's see. For suppose R1 is equal to robot chitti, we already defined. Okay, let's remove sensors. It is taking time. Okay, okay, let's see. And one more robot I am creating, same with same class. Sorry, R2 is equal to robot the class robot we are calling. From the class we are creating one more robot, some X. Okay, battery level is 80. Here each object has its own memory, right? Each object has its own memory, has its own data. This allows scaling. This is called scaling. From the same, by using same class, same object, we are scaling the robots. We are improving, we are increasing the count of the robots. This allows scaling. AI systems often create many agent objects, right? AI systems often create many agent objects, many tool objects. Let's see some real, we can call this, we can simply print R1, print R2, like that you can. Now let's see real AI examples, like chatbot class, how to create chatbot class. Let's see. First, suppose I am defining a class. In that class chatbot, I am creating define dunder init. I am initializing constructor using, this is a constructor. I am using constructor, self constructor, self dot, sorry, not dot, comma, name, column. Here I am calling that self dot name is equal to name, and self dot history it should store. Okay, whatever the in chatbot we are querying, it should store the history, right? Previous charts. So I am creating one list to maintain in a list format. I am creating history list. Okay, now again I am creating one more function, diff, one more function. The function is add messages, add message to the self role text. Here two variables I am taking, sorry, parameters. Self dot his, I will explain, history, self dot history to append into the list. Append in which format? Some list, some dictionary format, keys and values. Role is equal to normal role, comma, text is normal text, the text messages what you got, right? In this, now again let's see, declare to get the history, we have to define one more function, right? It will collect the history. Now diff and underscore show, not add, sorry, show history, history self for message in self dot, I will explain, one second, let me write history. Here print message role, the role, comma, message text. Okay, in this way we have to write. Here print statement is wrong. Here in this way we have to write. Here now what to do, we create a functioning class for a chatbot. Like this we have to create a chatbot class. From this, like simply bot, we have to create a bot variable. Now let's create chatbot, right? Chatbot AI bot, bot dot add underscore me, add message user underscore hello bot dot, I will explain first, let me complete that program. Bot dot add message, again assistant here, hi, how can I help? What that? Show history, right? Here, for suppose, one second, execute it. What it given? User, you just for suppose ChatGPT, you given hello. That ChatGPT assistant, what it will give? Hello, how can I help you? Right? Like this it will give, right? Here this is exactly how LLM conversation memory works. Yeah, now let's see the explanation. Why? Here now this section is extremely important because here we are not learning theory, we are learning how real chatbots remember conversations, right? What you are seeing here is a simplified version of how ChatGPT itself works. Okay, so let's go line by line without skipping anything. I will explain one more time. Okay, let's see. Here again I am telling this line defines a class named chatbot. Okay, remember a class is a blueprint, not a chatbot. Okay, this line only says here is the design of a chatbot, like that. Okay, no memory yet, no messages yet, nothing is alive yet. Now let's come to second line by line I am telling. Okay, line by line. In second line, the birth of bot, the bot. Here that second line we can call the birth of the bot, nothing but this is the constructor function. This function runs automatically when we create a chatbot object. Okay, the function runs automatically when we create a chatbot object. What I told, the function runs automatically when we create a chatbot object. Okay, think of this as the moment the chatbot is born, the parameter we have to name it, right? Parameter name allows us to give each chatbot its own identity. The parameter name gives an identity to the object. Okay, now let's come to that storing bot, that self dot name. What is this? Here the third line, what is this? Here we store the chatbot's name inside the object. We storing the chatbot's name inside the object. Self dot name means this chatbot's name, whatever it may be. The chatbot is a chatbot or a Chitti, a Terminator, whatever it may be. It is storing in that self dot name, the name storing in self dot name parameter. Okay, every chatbot object can have a different name. We can like Chitti, Terminator, like Megatron, Bumblebee, like that. Here we are creating conversation memory initialization, self dot history. Here conversation, here history. In that list we are creating a history list. For suppose some queries we will search in chatbot, that previous queries also there, no previous searches, we can see previous charts. All the charts will be maintained in a history list format. That square brackets nothing but it's a list format. Okay, this is most important line in this class. We are creating an empty list called history. This list will store the entire conversation. Okay, this list, user messages, assistant replies, like that. In real LLM systems, this is called conversation history. Okay, here if a chatbot has no history, it has no memory, and without memory intelligence will collapse. Okay, that is the main emphasis. Like it's if a chatbot has no history, it has no memory, right? Like that. That's why we are maintaining, while creating chatbot, we have to maintain history also in an empty list. Now adding a message like memory write. Here we are defining a function add message. What it is actually, what it is doing, this method is used to store messages. Here the role tells us who is speaking, user or assistant. The role is telling, will role tell us who is speaking, user or assistant. Like text is the message content, right? Text is the message content. Here the strong structure we are appending this line. What is this? However, we are appending a dictionary into the history list. We are appending dictionary. This entire thing, see, this entire thing will be entered into here like this. It will create a append means add. It will create one role and text like this. Each message is stored as role and text. This structure is not random. This is exactly how OpenAI, Gemini, Claude store conversation messages internally. Okay, very important insight is an LLM does not remember text, it remembers structured messages. Okay, structured messages only it will remember. LLM, just next chapter onwards we are going to discuss LLMs, AI agents and all. So very important. Okay, very important insight this is. An LLM does not remember text, it remembers structured messages only. Okay, here showing conversation history. Let's see. This showing conversation history. This method is used to read the memory. Okay, it does not change anything, it only displays what the chatbot remembers. Okay, next, this for messages in self.history. What it is, here we loop through each message stored in history. We are looping each message stored in the history. Okay, each message is one dictionary containing, each message is one dictionary containing role and text. In that role and text it is containing. Okay, next the line is, what is that? This line, print line. This line prints the conversation in a readable format, like user messages and assistant messages, exactly like a chart screen. Okay, now let's see the usage. Bot is equal to like we are creating a chatbot object, right? Here chatbot.ai bot we are creating. For suppose now we create a real chatbot object. At this moment what it will do, that initialization, dunder initial is there, no? Here this one, what it will do, it will runs and name is stored. Okay, it runs, the name is stored, history list is created, the chatbot is now alive. Now what will happen, adding user messages. Here we store the first message, hello. Okay, adding message, first one is first message, the chatbot now remembers and user said hello. Okay, user said hello. For that this one it will add what it is. For suppose now we store the assistant reply, it will store that assistant reply also. The chatbot memory now has user messages there in the chatbot memory. In history here it is user message is there and assistant reply is there, right? Displaying memory here, this is bot.show history. Temporarily if you query something, this type of functionality will happening before you getting any reply. Okay, here now we ask the chatbot to show its memory. Here it loops through history and prints everything, right? Here this output, whatever the output we got, here the output we got, hello user, hello assistant, right? The output proves one thing, the chatbot remembered the entire conversation. This is not magic, this is just object memory, that's it. We are creating a list of the memory, role and text format we are creating. Let me say this clearly, like This small program shows the core idea of LLM memory. In real systems, history is larger. Messages are sent to the LLM, responses are appended back, but the idea is the same. Okay, class holds memory, methods update memory, LLM reads memory. Here, class is there, methods are there, LLMs are there. What is the LLM here? Here, class chatbot is the class. Methods, what are the methods? Whatever the functions we used inside the class are called methods. Here, add message, show history are the methods. Methods update memory. Memory nothing but history. Okay, history nothing but memory. LLM reads memory. Here, bot, this is the LLM reads the memory. Right, here LLM don't remember conversations. Developers build memory for them. Okay, developer build memory for them. Okay, this is exactly how LLM conversation memory works. Now let's see some encapsulation, like data protection. Let's see some data protection, like I am commenting this one also. Let's move to further. Encapsulation nothing but hiding internal data. Now for suppose class is equal to some bank account is there. Bank account class is there for banking sector, not is equal to define a function diff dunder initialize it. Whenever you define a class, definitely initialization required. Okay, and self is common, this is common, remember, and colon, and self dot dunder balance is equal to 0. I will explain, wait. Here again I am creating one more function, one more method, deposit self is self. Okay, my amount, deposit amount, self dot balance plus is equal to amount. Already some amount is, some balance is there. For that it will add deposit amount. I will explain. One more function I am creating to show the balance, means history, right? Total balance self dot dunder balance. Okay, here let's see. Now let's see what is this programming block, what is this class, what is this blueprint is for. Okay, what is this class? Bank account class. What is blueprint is for? Now we are entering one of the most important ideas in object oriented program. The idea is called encapsulation. That encapsulation simply means protecting internal data from direct access. In real life, you don't directly touch your bank server to touch your balance. Okay, you don't directly touch your bank servers to some change your balance. Sorry, you go through some proper methods. This is exactly what encapsulation does in code. For suppose the class definition, class bank account is there. This line defines a class named bank account. The class represents a bank account blueprint. Okay, not a real account at, just the design of how a bank account should behave. Okay, now initialization, this is second line. Second line is this is the constructor method. It runs automatically when a new bank account object is created. Okay, whenever, not only whenever the new bank account is created, this all these things, if you call all the, it will automatically run. Okay, when a new bank account object is created, think of this as like opening a new bank account. Okay, now let's see this one, self dot dunder dunder balance. This is the most important line in this entire program. Why? Notice the double underscore before balance. This is called dunder dunder balance. I already told. Okay, in Python, double underscore means this data is private. Finally, double underscore nothing but this data is private. That means outside code should not touch it directly. It should only be changed internally. This is data protection. Why double underscore is used? If we wrote only self dot balance is equal to 0, anyone could do this, like account dot balance is equal to 1 lakh, the 1 lakh, like that. That would be dangerous. Be like here, by using dunder balance, we are telling Python language, please protect this variable, dunder balance variable, please protect it, like that, right? Here that important note is here the name mangling, like internally Python changes dunder balance to something like dunder bank account dunder balance, like that. This process is called name mangling. What is that? Name mangling. It prevents accidental access. Okay, it prevents accidental access. Now let's see deposit money. Here we are creating that, this one we created this method to deposit money. Here this method is the only legal way to add money to the account. Just like in real life, you must go through the bank system. Okay, here we are updating the balance. Notice something important here. Even though dunder balance is private, the class itself can access it. Only outsiders are blocked. Within the class you can access the dunder balance. We can't access dunder balance outside the class. Okay, I will explain, no worries. Okay, this is controlled access. Okay, dunder balance have some controlled access within the class. Now show balance. This function, what is telling? This method is used to read protected data safely. Users cannot see the balance directly. Okay, users cannot see the balance directly. They must ask the account to show it, right? Like this, show balance self. Here like this, print this prints the balance from inside the class. Again, here only the class is allowed to touch private data. The class is allowed to touch private data. How this works in real time? Let's see. For suppose account is there, SSUO U, and account is equal to bank account is there. For that bank account, we deposit something. Deposit 500, you deposited. Now account dot show balance. If you print like this, what it will show? It is showing error. Actually what it happens, a new account is created. We have created a new account, right? Balance starts at 0. but deposit adds money, balance is shown safely. At no point did we directly touch the balance. Here what is prevented by encapsulation? The account balance. Here why it is showing error? What error it is showing? Let's see. Attribute error, bank account has no attribute. Here let's try to debug it. Why this error it is showing? Self dot balance is equal to amount. Why? Bank account. Let's see that attribute error. Object has no attribute. Whenever Python throws an error, it is not angry, it is just explaining something very precisely. So let's decode this message step by step. Now class bank account is there. Okay, here we define self. Now here dunder dot balance is equal to 0, right? Here we created a variable called dunder balance with double underscore. Okay, this is not a normal variable. This tells Python that this variable is private. Okay, now let's see here what Python secretly did. Python does not store dunder balance with the same name. Internally Python changes the name to protect it. That is, internally converts this self dot dunder balance, right? That self dot dunder balance into it will change this into self dot dunder bank account dunder balance, like this. It will change like this. This process is called name mangling. I already told. It prevents accidental or direct access from outside the class. Yeah, why that error we got? Attribute error, bank account object has no attribute. Here Python is saying something very specific. I searched for a private variable but I could not found it. Here what is that? We missed to initialize the initialize spelling in it, right? Here init in it. So we missed that spelling, that's why it is showing error. We have to, yeah, now we got that, we got the response 500. It acts. See, if you change 5000 it will give like this. Python is case sensitive also. Okay, and also spellings also should be clear, right? Here inside the class always use the original private name, the dunder balance, right? This error happened not because of logic but because of just naming discipline. Okay, in encapsulation, constructor name, class name and underscore count must be perfectly consistent. Okay, what are the golden rules? The constructor must be init and dunder init init dunder. Okay, class name must match exactly. Private variables must be accessed only as dunder name inside class. Python is case sensitive. These are the main basic rules. Here what is the big realization? This error proves you are learning real object oriented program, not toy examples. These are the same mistakes even professionals debug. Okay, let's see. Now let's see another section, another topic code reuse, how to reuse the code, like inheritance. Okay, let's comment this program. Inheritance nothing but inheritance allows a class to reuse another class. How to reuse class in class? For suppose here class robot is there. Let's create one class robot. Here I am defining giving them functionality, giving method, speaking method. Okay, for this robot speaking method, I am a robot, like that. I given, okay, I given one functionality to this robot, and again one more blueprint I am creating. Creating means another robot I am creating. Combat robot, I created combat robot. For this, while creating second robot, I want speaking method from the first robot. I am calling that function. To inherit the quality of the first robot to second robot, right? Varsatvam, like inheritance, right? That's why I am inheriting the qualities of the first robot, like this. I am calling function in function. Sorry, not call function, it's a class in class. Okay, again define. Here this is an attack robot, that is normal robot, this is attacking robot. For suppose while in Robo movie, Rajani sir created Chitti robot, but the villain created with red chip robot, that is destructive robot. Rajani sir give normal robot to creating power, it can create number of robots, but the villain give destructive power. Okay, but he inherit the qualities of creating multiple robots, but with destructive mode, like that, right? Same inheritance here it is following. That first robot can speak, but second robot can speak and attack by inheriting the first robot qualities. Okay, same quality, like some type of crossbreeding. Here inheritance nothing but crossbreeding, like this. That robot we upside we define. Now let's see how can we call these. We have to call these by some variables. C is equal to combat robot. We are calling with variables. That variable C is equal to, now we define variable, we put all the data in variable C. Now we are simply calling, if you call the C dot speak, it can speak, the robot can speak. C dot attack, the robot will attack, like that it will. Here the output, let's see the output, what it will get. I am a robot and attacking enemy, like that you will get. This is called like parent to child relationship. This type of parent to child relationship. The parent is robot and child is combat robot. Let's see here. Yeah, this is the parent class, and the second one is the child class. This is called parent child relationship. Okay, now let's move to another section. Okay, let's see some another section. Let's comment it. Now we will see polymorphism. What is polymorphism means? Here polymorphism nothing but one command many behaviors. Let's see what is polymorphism. Now we are entering one of the most powerful ideas in object oriented program. Let me write the program. I will explain step by step. Okay, I am defining robot. This robot, what it will do, it's the robot can work any type of work it can do. Okay, the class represents a general robot, and it can it is a parent class. We can think like a parent class. The robot can work. This class represents a general robot. Okay, not a medical robot, not a police robot, just the idea of a robot. That's it. Now we declared work method. This method defines what any robot can do. Okay, like a generic behavior. Now I am creating medical robot. This class inherits from the above robot. See the robot, same inheritance we use. The word inside brackets tells Python medical robot is a robot. This is called inheritance. Okay, medical robot gets everything that robot has. Later this diff work self, that printing surgery means here something important happens. The method name is the same work. The method name is the same, that is work, but the behavior is different. This is called method overriding. We are telling Python when this robot works, do medical work, like that. Now we are creating police robot. Let's see the police robot. What to do? The police robot, this is another specialized robot we are creating. Again, it inherits from the robot. Let's see. This means it follows the same contract, that above contract we created. Now the contract created, that is robot. Same here, this is the another specialized robot. It inherits from the robot, the above robot. Here again we are defining work, same name method with same name, self, and print maintaining law and order. It will do some law and order work, right? Same method name, completely different behavior. This is polymorphism in action. This is called polymorphism action, like on type of aparachitudu, right? Polymorphism in action. Okay, now let's see creating multiple robots from the above. Here we can create a list of robot objects. Like here, noticing something important, we are not storing them as medical robot or police robot. We are storing them simply as robots. See, simply as in a list of robots, simply. Later we have to call them, calling the same method. We are calling the same method. Robots, we are creating a list of the robots. Now we have to call the robots with robots. For R in robots and R dot work. What type of? Based on the work. Here, now this is where polymorphism shines. We call the same method work on every robot, right? We don't use if we don't check type. We simply trust the object. See, simply the performing surgery, maintaining law and order. Here what it is doing, Python automatically decides which version of work to execute based on the actual object type. Okay, Python actually decides which version of work means policing work or surgery work, like that. This decision happens at runtime. This is called dynamic dispatch. Okay, here what happened, the big realization is here very important. The loop does not care what kind of robot it is dealing with, right? See the example, it is showing some error, some colon we are missing. We missed it, right? Yeah, it only cares that the robot can work on work function. Work itself is there, no, that one. This makes systems open for extension but closed for modification. Okay, actually in real world AI connection, in AI systems, polymorphism allows different tools with same interface, different agents with same commands, different models with same API. For example, in LLM, model dot generate parenthesis, like generate function. works the same way whether it is a GPT or Gemini or Claude, right? Here polymorphism teaches us one rule: write code that talks to behavior, not to type. Okay, this is how large systems remain flexible, scalable and clean. Okay, here the final line is same command different intelligence, right? This is polymorphism. Entire we can call this polymorphism. uh, why this matters actually? Without polymorphism, intelligence becomes rigid. Without polymorphism, systems become flexible. This is how robots, AI agents and real software systems adopt their behavior without changing the code that uses them. Okay, yeah, like this. Polymorphism means, what is that? Poly means many, morphism means forms, many forms. So polymorphism means one interface, many behaviors, or in simple words, same method name but different actions. Okay, that's it for the polymorphism. Now let's see another one, and the section like abstraction section, some advanced design we will see. Okay, we will stop, we will comment this and we will go to next section. Now we are entering the high level of object oriented programming design. Here what happened now? Here the concept is called abstraction. Abstraction means forcing a structure without defining behavior. Okay, in simple words, you decide what must exist but not how it works. Okay, what must exist but not how it works, we will see in practical examples. Right here, when systems become large, flexibility alone is not enough. Here, when systems become large, flexibility alone is not enough. We need some discipline. We need to guarantee that every agent, tool or module follows the same rules. That guarantee is called abstraction. Okay, here like let's see some inputting the abstraction tools. Let's see, write some code here. How to write? Let's see. For suppose abstraction is equal to some forcing structure. Here from ABC import ABC abstract method, like this. And here I will explain class agent ABC, and here at the rate we will use. Why we are using at the rate, I will tell. Abstract method we are calling defining run self. I will explain and give some pass for suppose, and again I am creating some child class. Okay, here class is drag agent and here agent, like this. Sorry, we are calling that above agent. Here class in class, drag agent in class. Now define run self. Okay, now print. What to print? Running drag pipeline. For suppose, let's see here what it will do. It ensures all agents flow same interface. For suppose here actually the above, what happens here, let's try to understand. From ABC import capital ABC abstract method. Here Python does not enforce abstraction by default, so we import tools from a module. Here ABC is a module. ABC is a module, so we import tools from a module called small abc. Okay, small abc is a module. Small abc stands for abstract base classes. What is that? Abstract base classes. These tools allow us to create rule enforcing blueprints. These tools allows us to create rule enforcing blueprints. What it is actually in real well, coming to this code here, what we did here, we define a class called agent, but this is not a normal class. By inheriting from capital ABC, we are inheriting from this capital ABC. We are telling Python this class defines rules, not behavior. Okay, this class is never meant to be instantiated directly, right? Here the important is you cannot create an object of an abstract class. It exists only to enforce structure. Okay, here the decorator is there. This decorator at the rate we will call as decorator. Now we see that at the rate symbol, right? This is a decorator, and here a decorator modifies the behavior of a function. What it will do, the decorator modifies the behavior of a function. In this case, at the rate abstract method tells Python any child class must implement this method. Any child class must implement this method. Okay, why decorators are used here? Without the decorator, Python would not enforce the rule. Enforce means to follow the rule, strictly follow the rule. That abstract method decorator run into a mandatory contract. Hey, here a pass is like an empty, like empty, nothing but the I am initially leaving this empty. Okay, like this. The base class does not care how the agent runs. It only cares that a run, this run method exists. Let's see. Abstraction separates what must exist from how it is implemented. Now let's see the child class implementing the contract. How to implement the child class definition. Here this is the child class. Here this class inherits. This class inherits from agent, right? That inheritance creates a rule. You must implement all abstract methods. If you don't, Python will raise an error like that. For suppose that below we given that method, this method. Here what it is doing, here we fulfill the contract. The method name is exactly the same, the run above same method we use. Now Python is satisfied, the agent is valid. What happens if you don't implemented it? If we remove run command, run method from drag agent, if we remove this, and try to create an object, Python will immediately fail. This is forced discipline, right? Like, this design ensures every agent has run. All agents looks the same from outside. Internals can be completely different. This is critically in large AI systems. This type mostly used in large AI systems, right? In real AI frameworks, every tool has execute, every agent has run, and every model has generate. The framework does not care what happens inside. It only cares that the method exists. Here, abstraction is not about hiding data. This is encapsulation. Abstract is about forcing structure. It guarantees that intelligent systems behave predictable at the architectural level. Here, in final conclusion, abstraction enforces discipline before intelligence is allowed to exist. Okay. Finally, you can say this like, the purpose is not decoration. Here, this is not for decoration. The purpose is contract enforcement. The @ is for contract and for enforcement, right? Now let's see some real agent architecture. Okay, let's see. Now let's see one more example. Let's now we go one level deeper. We will build a real agent, AI agent. This agent will decide what to do, choose the correct tool, execute it, generate a final response. This is exactly how ChatGPT style agents work internally. Okay, now let's see. We already from ABC import ABC abstract method, from ABC import capital ABC abstract method. Abstract ABC, what is ABC? Abstract base classes, right? That is definition. Class agent ABC we already define, an abstract method. Okay, this like this way. In abstract method, let's make some changes. Also add one more like query, query parameter. Okay, now this abstract class defines what an agent must do. Okay, what an agent must do. This now comment it. Here every agent must have a run method. Every agent must have a run method. I will tell what why what and what. Okay, no worries. We don't care how it runs. We only care that it can run or not. Now let's see some one more tool, like class is equal to tool ABC I am creating. Here @abstract method. Now diff execute self comma what to execute data. Now this also pass it. Okay, now we define a tool contract. I will explain. Every tool must implement execute, right? Every tool must implement execute method. This ensures all tools behave predictable. Now let's see some real tools. Here, for suppose class is equal to search tool is there. In that search tool, we are calling a tool. Sorry. We created a class. In the class we are calling the class defining execute self data print not so self data here print CHN searching for data. Okay, now return sample example. What is that? Rag retrieves relevant documents. Okay, execute. Now why it is showing execute overrides class tool. Let's see. These are just examples only. Let's see. Wait, let's create one more summarizer tool. Class summarize tool. Here also again tool and define no, sorry, pre-built it given automatically. Now print summarizing data. When summarizing data, return drag improves LLM accuracy, right? Let's create one more class 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 generate tool. What it will do? This tool diff execute self comma data. Which data? I will explain. Right, print generating final answer answer. Return final answer. Final final answer. What is the final answer? Simply data is the final answer. That's it. Here here what happened? Why it is showing error? Let's see. Change the capital letters then. Concrete agent, this fixes the this type of warnings. Okay, this fixes. Let we just we took some sample LLM how it will work. It's a passing data. We did not passing any values. No, we didn't write any code. That's why it is showing error. Red highlights these things. How it will be removed? Let's see. Let's create one other class CLA as a class and drag agent. Okay, now define here in real time. We will use dunder init dunder self we have to use. Now here self dot search self dot search is equal to search tool search tool. Okay, now again here itself you have to define self dot summarize self dot summarize is equal to summarize tool, and self dot generate is equal to generate tool. This is a method, right? Above also use method. Now let's see. Again define one more method, run method. Run what to run? Self query. I will explain. Docs is equal to self dot search dot execute query query. Now summary is equal to self dot summarize dot execute docs. I will explain 1 second. Sorry, what's happening here? Okay, here like this. Like this, and this is a method, simple summarize. That's it. Okay, let's go to return. What to return? Self dot generate dot execute summary. This is the actual LLM program. Okay, here why again it is running highlight? Now how to execute this? Agent is equal to drag agent. Now result is equal to agent dot run explain drag. In real time, while we are going to real time now, you will understand over this. Print result SULT. That's it. Here why it is showing error. Comment this. This is not required. Yeah, let me explain this entire code in a very simple way. First, we define rules using abstract classes. The rule is every agent must have run method, and every tool must have execute method. These rules ensure structure. Next, we create three tools. The search tool retrieves information, the summarize tool compresses that information, the generate tool creates the final answer using an LLM like logic. Then we create a real agent called drag agent. Inside the constructor, the agent stores references to these tools: self.search, self.summarize, self.generate. What we did inside the constructor nothing but dunder init is there, no? There the agent stores references to these tools. This is the agent's memory of capabilities. When we call agents.run query, the agent starts the workflow. Step 1, search the execute query, gets raw documents. In step 2, summarize.execute docs, cleans and compresses. And step 3, generate.execute summary, produces final answer. The agent simply passes data from one tool to the next tool. Finally, the outputs you see is printed. Here, important point: the agent does not search, summarize or generate. Tools do intelligence. Agent only orchestrates. Right? Here, the flow is user agent dot run and search, summarize, generate, output. Right? In this way, it will orchestrates simply, right? In real time also we will see this. This code is not about Python syntax, it is about AI system design. The agent coordinates, tools do intelligence, abstraction enforces structure. This is how real AI agents work. What happened? The agent will coordinates and tools do intelligence, abstraction enforces structure. This is how real AI agents work, right? The flow, already one more time I am repeating, the flow is user agent dot run, later it will search and execute, and summarize and execute, and generate and execute. Finally output we see here, right? No tool remembers past runs. The agent remembers structure, not content. Okay. Here, where is memory? There is no memory. Here, agent memory, tool references like self.search, pipeline memory, local variables, tool memory, temporary per execution. Right. This is the actual real world example. In depth we will see later. Don't worry if you did not understand properly. By practice you will get some more understanding. While implementing practically, at that time you will get some more knowledge, some more understanding. But keep practice, that's it. Python and agentic AI, keep practicing. While keep practicing only you will gain knowledge, right? That's it for the day. We are closing the session. In next session we will see some more in-depth concepts of LLMs and real agentic AI workflows. Until then, keep smile. Thank you so much. Bye.